Welcome. My name is Bradene Standen and I'm an occupational therapist at Latex. The focus of this presentation is on pressure reduction cushion materials or mediums, levels and features. The objective of this presentation is to explore the range of cushion materials and levels, provide examples of pressure reduction cushions, and to develop an understanding of the other available cushion features. I will begin by covering cushion materials and levels. Currently in Australia, pressure ratings are unregulated. There are no current standards available for cushions to be tested to. Suppliers may have the effectiveness of their products backed up with pressure mapping results or research. You can look into whether this research is available to view, however it may not always be. Consider if the research has also been completed by an independent body, and if not, the potential for bias. This highlights the value of understanding the different cushion mediums or materials in relation to pressure reduction levels, which I will go through soon, as well as the need for further investigation or assessment in relation to the person's specific needs. This may be done through trial of the cushions or through use of technology such as pressure mapping, which is currently available at Latex. Otherwise, if this is not done, you can only go by what the supplier states the cushion pressure reduction level is. To begin, there are both natural and synthetic sheepskins for use in beds and on chairs. They offer comfort and can also be placed over rough surfaces to protect fragile skin. Sheepskin is generally thought to be suitable for use with people at low pressure risk. There is an Australian standard that applies to medical sheepskin. This is AS 4480.1, 1998. You may inquire with suppliers as to whether their sheepskin meets this standard. There are also cushions with silicone-coated polyester fibre filling. The silicone coating lubricates the fibre to reduce friction and shear, but also to reduce moisture retention. They tend to be breathable, which reduces heat buildup. They are also washable and lightweight, but can be very dense. As a result, they require fluffing and are at risk of bunching. They tend to have a very short life expectancy as they can compress easily over time. Generally speaking, this type of cushion is suitable for someone who is just wanting comfort or is at low risk of developing a pressure injury. An example of a fibre cushion is the Spenco Silicor. It is made of Spenco Silicor fibres that are siliconized hollow core shafts. The supplier states that this product is suitable for people with low to moderate pressure injury risk. Foam cushions tend to have a short life expectancy, however may be less expensive than other cushions. Foam cushions lose their shape and support properties as the foam compresses with body weight over time. Therefore, these cushions need regular replacement, such as every 12 months. They are low maintenance and are generally permeable to moisture unless a specific seal or coating has been applied. They also tend to have good airflow, but some types can retain heat, such as the viscoelastic foams. Foam cushions are stable and can be cut to various shapes and sizes according to individual requirements and for custom seating or design, which will be discussed briefly later on. They can vary from low to high level pressure reduction, depending on a number of factors. Some of these factors are properties, density, quality, and layers. For example, the memory of the cushion. Memory is the ability for the foam to return to its original shape once the load has been removed. The slower the memory, the better the immersion the person can achieve. There are also open cell and closed cell foams. Open cell foams tend to absorb moisture, such as polyurethane foams. Closed cell foams absorb little moisture. They are often found at the base of cushions and have good shock absorption. An example is EVA foam. There is also an alternate type of foam called viscoelastic foam. It is a type of PU foam, but it has a different cell structure. It is less springy than regular PU foam, so that it conforms to the shape of the user and has a low memory, so it is slower to return to its original state after some time when the weight is removed. Another factor is density. Generally, the higher the density, the higher quality the foam. It may also be heavier due to the greater density, and thicker. This may mean that it gives more support and retains its support properties over a longer time. There are also layers in some of the pressure reduction cushions. Often there are more foam layers of varying densities in the higher level foam pressure reduction cushions. An example of a foam pressure reduction cushion is the Invacare Flowtech Contour Visco. This cushion is a high-density viscoelastic foam. It has a slow memory, and as a result, the supplier states it is suitable for clients at medium to high pressure injury risk. Another type of material used is latex, which is made from a natural rubber. It has an open cell structure and therefore tends to have good ventilation. It also tends to keep its shape better than many foams and is therefore more durable. It may last up to approximately 20 years for a high quality pure latex cushion. However, it does tend to be heavier than foam. Minimal maintenance is required and it can be cut to measure in different sizes and heights. It tends to have a low to medium pressure reduction level and may be good for people who experience allergies, as latex is less likely to harbour dust mites, although obviously it would not be suitable for people who have a latex allergy specifically. An example is the Aerofoam latex rubber cushion. Water is used in some fallout chairs, which are specialised pressure reduction seating. For example, water comfort chairs have water bladders in combination with foam. Water is not often used in cushions because it is heavy compared to other mediums, can be unstable for the user, puncture or leak, and is difficult to regulate by temperature and difficult to adjust. Gel is a common material found in pressure cushions. This is because gel conforms well to bony prominences, enabling the person to feel stable within the cushion. However, the thickness of the gel is important, as if it is too thin, the person may bottom out. However, also, if there is not enough gel, there is no or little immersion. Gel cushions come in various viscosities or thicknesses. Gel, unfortunately, can be heavy and floppy, which can make the cushions difficult to handle. As a result, you may find that gel is often attached to a foam base of support. Unfortunately, gel does not have good ventilation, so moisture may be an issue if choosing this type of cushion. It can also be affected by temperature, so heat may enable the cushion to soften a little, so it may be a bit harder in colder temperatures. The cushion can also conduct heat away, so it may feel cool in colder seasons. Gel is also waterproof, so it may be really good for clients who have incontinence. Minimal maintenance is required compared to other mediums. Some gel cushions are even self-healing, so if the seal is broken, it can be fixed. If it is not self-healing, patching kits are also available. The only disadvantage over a long time is that it may coagulate. Gel can be seen to be in either a solid layer, cubic, or lattice design. Scoring of the top layer of foam cushions or the cubing or lattice design of gel is to achieve greater surface area distribution or immersion. Often gel can be found from low to high pressure reduction. If it is a high pressure reduction cushion, it is more than likely going to be a cushion that has both a combination of gel and foam, which I will discuss later on. Equagel is an example of a gel pressure reduction cushion. It is made of dry polymer gel constructed in a lattice design. There are 4 models available with varying features. For example, some have contour and are customizable. Suppliers state different pressure reduction levels for the varying models of this cushion. The one on the screen is said to be for people at mild to moderate risk of developing a pressure injury, whereas a few of the other models are reported to be suitable for people at medium to high risk. Fluid is also often found in combination with other materials. Fluid conforms well to bony prominences, allowing for immersion. It moves with the body, therefore often distributes in areas where pressure reduction needs are higher, such as the ischial tuberosity. Fluid tends to not have memory, so the shape doesn't return after the weight is removed. As a result, there is a risk of bottoming out. It is important to ensure that the immersion is not so great that bottoming out occurs. This is where the depth of the cushion is inadequate under the full weight of the person, and the ischial tuberosities, or the sitting bones, are touching or very close to touching the bottom of the cushion or cushion base. Hence, there is no pressure relief. Fluid cushions are waterproof. However, they often need to be maintained or monitored over time. For example, they often need to be kneaded back into shape on a regular basis to enable immersion. It may also harden over time, and if the seal is lost, the fluid may ooze, which will reduce its pressure reduction properties, and therefore should not be used in this circumstance. Fluid cushions are often a high pressure reduction level material when used in combination. For example, they are most often used in combination with foam for a firmer base to allow for contouring. J2 and J3 cushions are a good example of fluid cushions. They have a fluid overlay which covers a foam contoured base. There is a deep pelvic cutout area in the foam which is filled by the fluid. The supplier of this product states that it is suitable for people at high risk of developing a pressure injury. Floam is an unusual liquid foam. It's fluid-like but light as foam. It adapts to changing positions of the person and conforms well to bony prominences. Similar to fluid, it has no memory, so it does not return to its original shape after being compressed. It may require kneading to return to shape, similar to fluid again, and is at risk of punctures. Generally, it is from a moderate to high pressure reduction cushion and is often used in combination with other materials to form a cushion. For example, the Autobot Cloud cushion is Floam cells on top of a foam base. The supplier states that this cushion is appropriate for a person at medium to high risk of developing pressure areas. Air is also a common medium for pressure reduction. There are both static and dynamic air options. Static is non-powered and dynamic is powered with alternating air. Dynamic air cushions are not commonly used due to the expense, weight and portability of this option. There are some examples of dynamic cushions on the market currently. For example, there is the Tele Trinity dynamic cushion and the Pegasus Proactive 2 cushion. There are many static air options. They may have pockets or compartments of air, such as those in the Viacare cushion in this photo, or they may have interconnected air chambers, allowing for air exchange between compartments when compressed. Both of these options enable immersion and enveloping. It is important with the cushions that have interconnected air chambers to not over or underinflate the cushion. Overinflating the cushion will not allow for immersion and surface area redistribution, whereas underinflation can result in bottoming out. Some cushions may allow for varying inflation pressures within sections of the cushion to provide more immersion in high-risk areas. Stability of these cushions is an important factor. Air cushions tend to be less stable and provide less pelvic stability. However, they may have very good shock absorption qualities. They tend to be lightweight, so are nice portable options, however may retain heat in warmer climates. Regular monitoring and maintenance is also required for this type of cushion. Regular monitoring is required to maintain optimal air inflation. If the seal is lost, air can leak quickly and the cushion will lose all its pressure reduction qualities. It can also puncture. An advantage, however, is that it is generally easy to clean this type of cushion. Air is a common medium seen in very high level pressure reduction cushions. However, you can find it in low to very high pressure reduction cushions. RoHo is one of the static, non-powered options. It uses what the supplier refers to as dry flotation technology. Air moves within the interconnected cells according to shifts in body weight. It distributes interface pressures across the cushion surface and away from peak pressure areas. The design of the individual cells is such that each cell moves independently with the user to allow it to adapt to the shape of the user, which reduces shear and friction as the user moves. Lastly, there are the combination cushions. These are some of the common combination pressure reduction cushions that exist. Certain materials are paired in order to make the most of their positive characteristics or to complement each other. For example, foam is used in many high-end cushions to form the base of support and to provide contouring within the cushion for postural support and stability. Air, gel, fluid or Floam may then be used as an overlay or bladder in high-risk areas to provide the immersion required for pressure reduction. In this diagram, I have provided some specific examples of current cushions that meet these. For example, the Varilite and RoHo Hybrid Elite are examples of foam and air cushion combinations. The Relax Gel Cell is a gel and air cushion. The Relax Duo Gel, J and Cloud are examples of foam and gel, foam and fluid, and foam and Floam cushions. Moving on from the cushion materials, I'll now talk a little bit about some of the other cushion features you may need to consider. Many cushions on the market have features that support positioning in addition to the pressure reduction features or materials. Some of these features may include pre-contouring. Pre-contouring is used to increase postural stability. For example, the foam is shaped to form leg troughs to promote lower leg alignment and shaped around the buttocks for greater stability. There may also be varying compartments within the cushion itself that can be altered individually. For example, there may be two compartments, one on either side of the cushion, that can have varying inflation levels in order to support a pelvic abnormality. There can also be modular components or accessory pads that can be used to customize the cushion to increase pressure relief or for positioning. The ability to cut the cushion to size or requirements is also an advantage. For example, you could use this feature to account for a leg length discrepancy. Cushion covers also play their part in pressure reduction. You should always use the recommended cover for the particular model of cushion, as an inappropriate cover can reduce the effectiveness of the pressure management properties. Similarly, there should never be other objects placed between the cushion cover and the person, such as sheepskin, as this will reduce the pressure reduction qualities of the cushion as intended. Not all covers are removable. This may influence the suitability of the cushion for a particular environment or person who has incontinence. The direction of the cover is also important. Some cushion covers have written indicators on them for the front and rear of the cushion. Therefore, it is important to put the cover on correctly to avoid the cushion being placed on the wheelchair in the incorrect manner, such as back to front. There are some non-skid bases on some of the cushions. This may be texturized or have Velcro and helps to keep the cushion in position on the wheelchair seat base. The seams of the cushion covers also come into play. You need to monitor the signs of wear and tear of the seams. Cushions are either stitched or heat welded at the seams. Stitching may allow fluid, such as urine, to seep into the cushion. Because of this, welded seams tend to be of better quality. There may be waterfall flaps over the zippers to protect the person's skin from the zip itself. Some covers also have handles built into them to promote ease of handling for the cushion. The cushion cover fabric itself can have an important influence on the pressure reduction quality of the cushion. The type of fabric can influence its water resistance, so whether the cover is waterproof, its vapor permeability, so this is quite important in hot climates, and whether it has antimicrobial protection, which protects against moisture and bacteria buildup. Laundering is also a common factor. The type of fabric affects how well it can be laundered. Covers should be washed or wiped down regularly. Flammability is also an important factor and is often one that you can find more information about from the supplier. The ability for the cover to stretch is very important. Stretch is important as it reduces friction and shear and promotes comfort and dispersion of body weight. Conformability, as I've already discussed before, is also important, not only for the cushion itself, but also the cushion cover. Finally, I would like to summarize the important take-home messages. There are a number of different cushion mediums, which vary in their pressure reduction qualities. Investigation of the specific person's needs and trial of cushions is required to make an informed decision. You can contact LifeTech for particular equipment questions and trial. I would like to finish by saying that our door is always open. Thank you very much for listening.